Christian Huygens, an outstanding Dutch scientist of the 17th century, the creator of the first wave theory of light. He believed that in a homogeneous medium, light from a point source propagates in spherical waves. Huygens represented this process as follows. Each point of the medium reached by the light disturbance itself becomes the source of a new, secondary wave. This description of wave motion became known as Huygens' principle. According to this principle, the new position of the wavefront is the envelope of the surfaces of the secondary waves. Knowing the position of the wave surface at a certain moment in time, its position in the next moment can be found. This makes Huygens' principle convenient for analyzing some cases of light propagation. Suppose we need to determine how light will be reflected from the interface between two media. Here, a plane wave falls onto the interface. Various points of this wave reach the reflecting surface non-simultaneously. Let's recap a bit and watch again. Waves from secondary sources begin to propagate even before the wavefront reaches point B. The surface touching all secondary waves is the front of the reflected wave. From the equality of the right triangles ABD and BAC, it follows that angles alpha 1 and gamma 1 are equal. Angles alpha and alpha 1, as well as gamma and gamma 1, are also equal since they are angles with mutually perpendicular sides. Therefore, angle alpha equals angle gamma. Thus, using Huygens' principle, one can prove the equality of angles of incidence and reflection. Now let's see how the image of a point source is formed in a flat mirror. A spherical wave propagates from the source. The front of the reflected wave is a sphere with the center at point O prime. This means that point O prime will be the virtual image of point O. It is not difficult to prove that segments AO and AO prime are equal. Therefore, the image of the point formed by a flat mirror is symmetrical to the point itself with respect to the mirror surface. Huygens' principle also proved convenient for deriving the law of refraction of light. In this experiment, a laser beam is directed into a vessel of water. The beam refracts. In his reasoning, Huygens assumed that waves in the second medium propagate at a different speed, different from the first medium. The difference in speeds causes the wavefront to change direction. From triangles ACB and ABD, we find the relationship between angles alpha and beta. But the ratio of the sine of angle alpha to the sine of angle beta equals the refractive index. Thus, the refractive index turned out to be equal to the ratio of the speed of the light wave in the first medium to its speed in the second medium. In his theory, Huygens did not use the concept of the periodicity of light disturbances, and therefore his principle describes only the phenomena of geometric optics.